In this video, we're going to look at the quadratic formula in a lot more detail, and specifically one particular part of the quadratic formula called the discriminant. Now, we're very used to dealing with the quadratic formula to solve equations from GCSE. What I'm interested right now is how many solutions does a quadratic equation usually have? So in general, my quadratic equation, ax squared plus bx plus c equals 0, and we know that we can find these solutions to that by using the quadratic formula written on the right-hand side there, the minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now, you'll remember that we do this formula twice. Once when we add, and then we repeat the process when we subtract. And most of the time that gives us two different solutions. But that's not always the case. For example, if b squared minus 4ac were to equal 0, then this would equal 0. And the square root of 0 is 0. And minus b plus 0 is just going to be minus b. And minus b minus 0 will just be minus b. So notice in this case, we've actually ended up with one repeated solution. They're the same answer, minus b divided by 2a. So if b squared minus 4ac is equal to 0, then we get one repeated solution, rather than the two that we're used to. What about if b squared minus 4ac is less than 0? If it's negative? Well, the issue there is if this is a negative number, then we're then going to try and square root a negative number. Now, there are no real solutions to that. You can't square root a negative number and get a real answer. You can get complex solutions, and those of you that do further maths will learn about that. And the rest of you, if you're interested in complex numbers, do ask me. I'm happy to explain that to you. It's quite interesting. But in terms of real numbers that we are used to dealing with, there is no solutions to it. And therefore, because we can't square root that negative number, there is no answers at all to the quadratic equation. So, we've basically got three different options here. If the b squared minus 4ac is negative, then there is no solutions. If the b squared minus 4ac is 0, then there is one repeated solution. And the third option is if the b squared minus 4ac is positive, and that's when we get the two solutions, like we normally are used to. So that b squared minus 4ac is a really important part of the quadratic formula. We call it the discriminant because it discriminates between those three options that I've just talked about. If the discriminant, if the b squared minus 4ac is negative, then we know that the quadratic equation has no real solutions. If the discriminant, the b squared minus 4ac, is equal to 0, then we know we have one repeated solution or one repeated root. Or if the discriminant, the b squared minus 4ac, is greater than 0, then we know that we have two distinct roots, two distinct solutions. So, just by looking at the discriminant, just by looking at the b squared minus 4ac, it tells us about how many solutions a quadratic equation is going to have. So, we've got a quadratic here. We've got the x squared plus 4x plus 12. Let's calculate its discriminant. So b squared minus 4ac. The b is 4. The a is 1. And the c is 12. So 4 squared is 16. 4 times 1 times 12 is 48. And 16 minus 48 is minus 32. So the discriminant is negative, it's less than 0. Therefore, there are no real roots. Which means I know that this equation has no solutions. Graphically, what that means then is it is not going to intersect on the x-axis at all. It will never equal 0. So when I come to sketch this, I know it's going to cut through at 12. I know it's a positive x squared, so it's going to be a U shape. And I know that it will not cut through on the x-axis. So it's going to look something like this. And if I wanted to work out the coordinates of the turning points here, I could do by completing the square. But that's not the point here. The point I'm trying to make is that the graph will look like that and not like that. That would be wrong. That would be cutting in two places with two distinct solutions. This has no real roots, so it'll look something like that. Next, we've got 2x squared plus 7x minus 10. Again, let's calculate the b squared minus 4ac. So the b is 7. So 7 squared minus 4 times the a is 2. And the c is minus 10. Don't forget that minus 10. 7 squared is 49. Minus 4 times 2 times minus 10 is plus 80, which gives 129, which is greater than 0. So therefore, I know that there are two distinct solutions, two distinct roots. So I know my equation has two solutions, and I know it's going to intersect on the x-axis twice. I also know it's going to intersect at minus 10 on the y-axis. And I know it's going to be a U shape because of the positive 2. So it's going to look something like this, where it intersects on the x-axis in two distinct places. Third example, minus 2x squared minus 8x minus 8 is equal to 0. So again, let's have a look at the discriminant here. B is minus 8. Minus 4 times A is minus 2. Times C is minus 8. So this gives me 64 minus 64, which equals 0. So therefore, I know that there is one repeated root because the discriminant equals 0. So this equation will have just one solution. In terms of sketching this, I know it's going to intersect at minus 8. There's my minus 8. I know because of the minus 2 here, it's going to be an N shape. And the fact that it has one repeated root means it's just going to touch the x-axis in one place. So it's going to look something like this, where it touches the x-axis in one place there. So that's how we can use the discriminant to get an idea of how many solutions an equation has and what it might look like graphically. Let's have a look at 3 more examples where we're solving slightly harder problems here. So, in this question, we are told that the equation x squared plus 3px plus p equals 0, where p is a non-zero constant, has equal roots. We need to find the value of p. So what value of p here means that this equation has equal roots? So equal roots means that the discriminant b squared minus 4ac is equal to 0. So my b is 3p, that's b. So b squared minus 4 times the a is 1, times the c, which is p. And that has to equal 0 for there to be equal roots. 3p squared is 9p squared minus 4 times 1 times p is 4p. To solve this, I can then factorise a p outside. And then I can see that either p would have to equal 0 or p would have to equal 4 over 9. In each of these cases, if I put 0 here and here, then I just get the equation x squared equals 0, which makes sense about why there is equal roots. The only one repeated root there is 0. Or if I substituted 4 over 9 in here and here, then that equation would have equal roots. If I wanted to know the actual solutions, I could use the full version of the quadratic formula, but that's not what this is about. This is just about finding the values of p that would make the equation have an equal root. The other thing about this question is the fact it says non-zero, so I'm going to eliminate the fact that p is equal to 0, and therefore p is equal to 4 over 9. Next, we're told that the equation x squared plus kx plus 8 is equal to k has no real solutions. So that sentence there, no real solutions, is telling me that the discriminant, the b squared minus 4ac, has to be negative. Now, I want to, in order for me to use the quadratic formula, this has to equal 0. Remember, to use the quadratic formula, your quadratic equation has to equal 0. So the first thing I'm going to do is subtract that k from both sides. Right, now my a is 1. So a is 1. My b is k. And the c is the term without any x in it at all. So the c is the whole 8 minus k. Right, let's substitute those into the discriminants then. So my b squared minus 4 times a times c has to be less than 0. The 4 times the 1 is just 4. And let's expand those brackets. So the 4 times the 8 is 32. And then the minus 4 times the k is plus 4k. The minus 4 times the minus k there gives me the plus 4k. And that has to be less than 0 for there to be no real solutions. We've got a quadratic inequality to solve here, so let me factorise this to find the roots. And like we always do with quadratic inequalities, we're going to draw a little sketch. I can see that the roots are going to be at minus 8 or plus 4. Minus 8 from here, plus 4 from here. So I can draw my quadratic inequality like this. And I'm looking to see where is my discriminant less than 0? Where is it negative? I can see it's negative for all of the values in between minus 8 and 4. So that's my range of values for k, where this equation has no real solutions. So if k was -7, -6, 0, 1, any values between -8 and 4, then that equation would have no real solutions. Right, last example, and a slightly trickier one. We are told that the curve C has got the equation y equals 2x squared plus kx plus 7, where k is a constant. And we're told that a line L has got the equation y equals 3x minus 1. Given that the line L intersects with the curve C twice, finds the set of possible values for k. So intersects makes me think simultaneous equations. Twice makes me think that it's going to have two solutions. So let's do that. Let's do simultaneous equations. I'm going to substitute this 3x minus 1 in instead of the y there. So I can say 2x squared plus kx plus 7 is going to equal 3x minus 1. Right. I am now going to move everything over to the left-hand side. So I'm going to subtract the 3x from both sides. And I'm going to add the 1 to both sides. Now, the next thing for me to do is, because I know that it's going to intersect twice, I know that this equation should have two solutions. So I'm looking for its discriminant, the b squared minus 4ac, to be greater than 0. If there's two solutions to this quadratic equation, then the discriminant should be positive. So let's see. My a is 2. Now, the b is the coefficient of the x term. But you'll notice here that I've got two x terms. So what we must do is factorise that x outside. If I factorise the x outside from here and here, then I can then rewrite this as k minus 3 times x. And now I can see quite clearly that the b, the coefficient of x, is k minus 3. The c is the number on the end there, which is 8. Right, let's use the discriminant. So b squared minus 4 times a times c has to be greater than 0. Let's expand these brackets. The 4 times the 2 times the 8 is minus 64. We can factorise this to find the roots and draw a little graph to solve this quadratic inequality. I can see it's got a positive root at 11 and a negative root at minus 5. And we're looking for when this is greater than 0, which is going to be all of the values over there and all of the values over there. So if k is less than minus 5, all of these values here, or if k is greater than 11, all of these values over here, in either of those cases, then that straight line would intersect the curve twice. Now, just to show you very quickly what that means graphically, here I have, in green, I've got the y equals 2x squared plus kx plus 7. And at the moment, k is set to be 2. As I increase k, so you can see the changes to the green graph as I change the values of k here. So at the moment, you can see that when k is 2, the green line does not intersect with the red 3x minus 1 at all. if I make k become 5, so if I make k become 11, you can see at that point there, they touch. If I make k bigger than 11, you can now see that they do intersect in 2 places. If I make k equal to -5, then you can see there that they touch at one point. If k is less than -5, then again they intersect in 2 places. So hopefully that makes sense graphically where we got these solutions from.